First of all, we recognize that these are log equations, that the x is inside of the log. So we go through our steps, and we want to combine as a single log, change to exponential form, and then solve. How many logs do we have in the first one? 3. Can you see that on the right-hand side of the equation you're adding? So what could you do? You could combine those by multiplying inside. How many logs do we have? Still have 2. How would we combine our logs to a single log? Well, we would need to put those logs together. The only way we could do that is if we had our logs on the same side. So I'm going to subtract this one on both sides. Careful, when you subtract something from both sides and nothing's left on the other side, it's very tempting to write nothing, which is very bad in an equation, because you can't solve this. This isn't anything to solve. So you need to make sure if I take away everything from one side, I still have to write equals 0. How do I combine if I'm subtracting? Divide. So I would get log of 6x would be on the top, and x plus 6x minus 1 would be on the bottom, equals 0. Now we've got a single log. It's got a lot of stuff in it, but it's still a single logarithm. What's the base? 10. What's the exponent? 0. Equals 6x over x plus 6x minus 1. What is 10 to the 0? 1. If I want to get rid of, this is a rational equation. How do we solve rational equations? Well, we like to get rid of that fraction. So can you see that if I multiplied both sides by x plus 6x minus 1, that would get rid of the fraction on the right? What would I be left with? Well, we already said 10 to the 0 is 1, so this side will just be x plus 6, x minus 1, and this side will be 6x. So what happens in the solve for x part of a logarithm equation is you get something you've seen before. This is a rational equation. How do I solve rational equations? Well, I get rid of the fractions to work with that, and then see what I get. Now, what kind of equation do I have here? It's quadratic. How do you solve quadratic equations? Make one side equal to 0, multiply everything out. So I'm going to get x squared plus 5x minus 6 on this side equals 6x. If I make one side equal to 0 by subtracting 6x on both sides, I get x squared minus x minus 6 equal to 0. How do I solve that? Factor or quadratic formula. Luckily, this one factors. X minus 3, x plus 2, x equals 3, x equals minus 2. Yes? I can scroll it up for a second, yes. How far? Oh, where I got the 10 from. So this is the part where I asterisked it, the definition part, where I put an asterisk. What do we do in the definition? We look at the base. The base that's not written is a common log that has a base of 10. So usually there's a number there, but when there's not a number there, we know it's a common log with a base of 10. And that's how I knew this was 10. Here is my exponent. So that's why it's exponent 0, and what's inside of the logarithm is the answer. So we've got two answers, x equals 3 and x equals negative 2. The last thing we have to do is check. we plug it back into our original equation. So plug in 3. Here I'm going to get log of 18, positive number. Good. Here I'm going to get log of 9. Good. Here I'm going to get log of 2. They're all positive. So I go down to my answer and say that one's good. What about minus 2? Check the first one. 6 times minus 2, negative 12. As soon as you get a negative inside of a log, this is not possible. Okay? Careful, you have to plug it in. I can give you a question where both answers are negative and both answers work. So just because our answer is negative does not mean that it's going to not work. And just because our answer is positive, that doesn't mean it will work. I can give you a question with 2 positive answers and they both don't work. I can make up a question with 2 negative answers that they both work. I can make up a question where the negative one works and the positive one doesn't. So all of those are possibilities. We can't just say, oh, since my answer is negative, I X it out. I have to plug it back into the original equation and find a negative inside of a logarithm. No, because it's really easy mental math. So I plug in negative 2. I see that this is negative inside. No work needs to be shown. I can X it out and write not possible. And they'll assume that that must have been what you've done, because it is that easy. So we have only one solution to this one. Let's look at part B. Oh, before we go on to part B, part A is a special type of question which has a shortcut. Okay? Now, the shortcut doesn't always work, but in part A, there is a shortcut. And I'm going to show you that shortcut, and if you want to use it, great. But if you want to just know the steps, single log, use your definition, solve for x, that's fine as well. The shortcut comes right here in our first step. Okay? In our first step, once I got log of 6x on one side and log of something else on the other side, can you see in this step I have log of something, I'll put something in a red box, log of something equals log of something. What do you know about those somethings? They have to be the same. Does that make sense? Now this only works if you have log something equals log something. It's the same idea that we used in our exponent when we got the bases the same. Remember when we got our bases the same? Let's say you had 2 to the x plus 3 equals 2 to the 7. Well, 2 to something equals 2 to 7. What did we do next? We said something equals something. X plus 3 equals 7. And then solved x was 4. You could do that same thing here. Log of something equals log of something. As long as there's no like extra plus 1 on the end or anything extra, then this doesn't work. But if it's log of something equals log of something, then what you're going to get as your next step is you can just say, well, that something equals the other something. Oops. Log x plus 6, x minus 1. How many steps would that save us? That saves us a lot of steps in this one. Well, you can only do that if you have log of something equals log of something. Look in our first example that we did. Oh, we erased it. We'll look in our second example. You won't be able to do that. Okay? So here's example. We'll do part B. Good. I like the sound effects. I forgot I had my speakers on. In this one, again, we want to combine as a single log. We're always going to think about doing our steps. Single log, use our definition to change to exponential form, and then solve for x. If the shortcut comes up, where you have log on one side equals log on the other side, go ahead and use that. But in this case, here I have two logs, right? If I want to write it as a single log, I have a log plus a log. I can write that. Log law says that means multiply. Can you see that on the one side you have log, on the other side you don't have a log? Can't use the shortcut. But we have a single logarithm, and since we have a single logarithm, the base, by definition, definition, there we go. By definition, the base is 2, the exponent is 3, equals x plus 2 times x. If I multiply that out, that's x squared plus 2x. What kind of equation do we have? Quadratic. How do we solve quadratic equations? Make one side equal to 0. And factor. X plus 4x minus 2. So we get x is equal to minus 4 and x is equal to 2. We have to check these. What happens if we plug in minus 4? We get a minus 2 right away. So part of the thing I don't like about the examples out of the textbook is all of the examples of the textbook, the negative ones don't work, and the positive ones work. I don't like that because you get into this, oh, maybe that's a shortcut, and it's not. It's just a coincidence. So we have to be careful with that. Okay, questions 11 and 13. This afternoon, I will give you some more practice with these that will get you to know whether or not this doesn't always happen.